I will now introduce a software engineering topic in constraint programming, which is the invention of the domain and the variables view in order to make the solver much more flexible and avoid a lot of code reuse. As a motivation, let's consider the n-queens problem. So for the n-queens problem, you know that we had all these little binary constraints to state that not two queens can be placed on the same line or the same diagonal. And we have dedicated here the not equal constraint because we really needed this offset, you see, if you remember, to avoid the left and the right diagonal placement of the two queens. The problem with this is that if we want to specialize every type of constraint to take into account the possibility of possible offset, integer offset on the variables, then we might need an explosion of the number of constructors that we need. And so to avoid that, we have here another alternative model in which we have this little construct plus and minus that would apply directly the offset here computation on the variables and retrieve as a result a new variable so that we can avoid this blow up in the number of different constructors. Okay, so as an example, so if you want to apply an addition or multiplication, you would need to specify and specialize every constructor with a not equal plus, not equal multiplication, and so on. And so you would need many different types of constructors, and this would be a lot of ways because you will have copy paste everywhere. This is a source of bug. You need to maintain more code. You need to maintain more algorithms, and so we really need to discover a software engineering solution to this problem. Okay. And so how to implement this? We have an idea of what we need to avoid this. We need a new construct like the plus and minus, but how to implement this? One possibility is to introduce one new fresh variable for every type of expression, so that we have, for instance, x is equal to 1 plus 2, and then we have here equal to y prime, for instance. Okay, we want to do that. We may want to do this with a new equality constraint. The problem is that we will have many different types of constraints if we do that, and it will also be more heavy for the fixed point computation because all these little constraints that you will imagine will need to be propagated in the fixed point computation. Okay, so this is always a trade-off. Okay, and the question is, can we have the best of the two? So have the flexibility of this solution, but also without making the fixed point computation more heavy to compute. And the answer is yes, we can do this, and we will take some inspiration from the database community. As you know, if you use a software like MySQL, you can easily create views, and views are really like fake tables. You don't really have a new table that is created, but they will act exactly like a table. They will smell like a table, but there is no storage behind the scene. Everything is recomputed for you. And the idea is more or less the same with the variable views. Okay, so variable views will capture very simple relations, like they will be binary and injective. And we will take three examples of variables views. We will have the offset, the opposite, and the multiplication by a small integer positive number. And in order to implement variables views, we will rely on software design principle that is called delegation. So in practice, we will have one specialized class for every type of expression like this one, the offset, the opposite, and the multiplication. And this is the name of the classes that will implement it. And we will delegate it to the real variables. What we mean by delegation is exactly this. Assume that we have a variable y, which is x with an offset of 2, so x plus 2. If you ask me to retrieve the minimum of the variable y, which is my view, I simply need to query the variable x, and then before returning the result, I will apply a plus 2, since the variable y, the view y, is just an offset of plus 2 on the variable x. And the same for the update operations. So if you ask what is if 8 is part of the domain of the variable y, you just need to translate this query as is 6 part of the domain of the variable x. Okay, so you do 8 minus 2. 2 is again the offset. So the same for the update operation. If you want to remove everything below a given threshold, 5 for instance on the view y, you translate this as remove everything below the value 3 on the domain of x. So this is the delegation, and this is exactly the way we implement it inside the invar_view offset class. So invar_view offset class will implement this, and this is the interface. Okay, this is an interface. Okay, this is not an implementation. And so what it means is that inside the constructor, we receive x, which is also of type of the interface invar, which means that we could even be able to compose views. We could apply a view on a view, for instance, okay? And the implementation that I propose here is completely agnostic of this, okay? That we may want to compose views again and again. And so we will store the variable x and the offset, and we will simply delegate, just as I've shown before, all the methods. So if you ask the minimum, I return the minimum of x plus O. If you ask the maximum, it's the maximum of x plus O, and the same for all the update operations. So this is really a delegation that we are here on the variable x. And again, it's compositional, since we are only dealing with interfaces here, and this is also implementing the interface. Okay. So then we are able to use a variable view exactly like a real variable, okay? And so the constraints that we implement in MinCP, they don't know that. They just manipulate int_var, okay? And int_var, again, this is an interface. And since the views also implement the interface, my implementation of not equal constraint doesn't know if I'm asking to pose the constraint with a scope involving variables or variable views. They don't know that. What we have here is two simple methods. So we have factory method plus and minus that we have created to instantiate the views. And so as you might imagine, the plus is simply returning a new int var view offset. Okay, on x, on the queen of I, and then you will have g minus I. Okay, so this is what this static factory method is doing for us. It's creating the invar view offset. It just delegate, also creating these views for us. Okay, so let's summarize a little bit the views. The views is a very powerful software engineering way to have a more flexible software, a more flexible solver that avoid code duplication, for instance, to specialize every little operation such as an offset, such as a multiplication by a small constant.